Alright, welcome back. Today I'm going to be covering the Imars oscilloscope. It's an oscilloscope with a multimeter built in. It's got all the features, basic multimeter that we all are grown to be familiar with. But I'm doing a little bit of testing on the oscilloscope side that it might prove to be pretty interesting as well for the HVAC techs out here. So stay tuned, let me know what you think. So as you can see, we've got a 0.76 power factor, and this is what the waveform is displaying at 0.76. So you can see the yellow line is the amps, your amp draw, and the green line is voltage. So a unity power factor, meaning 0.99 to basically 1 power factor, would show both of those green and yellow would be perfectly aligned with one another, basically on top of each other. So this is just a new way, in my opinion, to check capacitors. Still doing some testing, but pretty cool device. So I'm really liking it so far. And this oscilloscope is also a multimeter. I can do everything from check amp draw, voltage, capacitors, everything. So what I'm going to do now, take this here amp clamp. I'm going to take the current for the inducer motor. Okay, so that's what the current for the inducer motor looks like. You can see it's much more ripply current, and we can check our power factor as well for that. 0.6. Okay, so that's the 0.6 power factor. Really powerful, really powerful tool. I'm gonna go ahead and check the current using the milliamp section and a current transducer. So we're just gonna go to amps, AC. I'm gonna go ahead and put that into milliamps, AC milliamps. Now I can take this current transformer, clamp that, 2.7. There you go. And we'll grab our amps from, and we'll grab the amps for the inducer as well. .5. And for comparison, we've got to, like I said, you've always got to stay away from this here motor, just because of the back EMF, magnetic field that's being induced from that. And get your current downstream. So you can see we got 1.8 there, we got 0.97. That's pretty close. Alright, and last but not least, we're going to demonstrate how to test a capacitor using this system. So I'm just going to take the red prong, pop it into there for capacitors, and as you can see, when you hit this, it'll show you where to place your probes. Right here, red, black for common. Then you just hit capacitor, F4 for capacitor. See where your nanofarads. Now, just grab these terminals off of here. Alright, so we got a 7.5 microfarad capacitor here. We simply put a lead on each side. This takes a while, I'm sure. There you go, 7.78. Okay, that's good. Okay, so now we're at a package unit here doing another gas maintenance, and this is going to be a 240 volt motor. I've got it all wired up here on the oscilloscope. As you can see, look how ugly that sine wave is for our amp draw. Remember, amps is yellow, the way I've got this set up, voltage is green. So you can see the amps, how basically cluttered they are, and that's because this is going to be an ECM motor, okay? And we're gonna take a look and see what our power factor registers as well. So I'm just gonna simply take, I've got one leg on the ground, I'm gonna take the other, take it to one of the legs of 240, We can see our power factor is 0.63 at 170 watts. So that's what a 0.6 power factor looks like. That's a 0.7 power factor, and that's 0.7 ECM waveform. I'm going to go ahead and pause it here. As you can see, I'm going to pause it, stop the waveform. And you can see, if you do the math on this, right, I'm going to zoom in. If you do the math, you can see this side here, the bigger, the side that's more aligned with the waveform. This is taking up about 13 segments, right? So we got 4 in each square. 4, 8, 12, and then about 13. This one is taking up 4, 5, 6, about 6. So if you do the math on that, 13 plus 6, 13 plus 6 is 19. So 0.7, because we got a 0.7 power factor. So if you multiply that times 0.7, you get 6. So it's showing you this is your power factor. It's showing 70% is going to be in phase with our voltage, and then the remaining 30% is going to be out of phase of our voltage. Okay, you can see once again, zoom out, and there you go. The bigger chunk is aligned with our voltage peaks, both on positive and negative, but then you have the smaller, skinnier portion that's out of phase of our voltage, and that's how that equals perfectly to what our power factor is. Now this doesn't actually give you a decimal readout for the power factor, but it shows you a visual representation of your power factor. Love this thing, man. Check it out. Alright, let me know what you think in the comments below. Thanks for watching. Okay, so I've got this set up on a unit. It's an older train R22 system. As you can see, the yellow line here is your current. Green line is voltage. I've got it set on basically only between one leg of power, so we got it set on basically it's only reading 120 volts between ground and line voltage. But as you can see, this amperage is really, the sine wave is very distorted, very messy looking. Okay, and that right there is just a indication of poor power quality on your current. You can see there, it's just not a very nice looking sine wave. And you can see here, I've got my Fluke 387 FC, and I'm checking the same current. Got the clamp here. This is the clamp for the oscilloscope. Here's the clamp here for my Fluke. You can see we've got a power quality fault there. That little indicator there showing power quality on your amps is low. So there's just going to be a lot of harmonic distortion in the line. I think it's really cool that you can actually verify harmonic distortion as well, both on voltage and on your current. So if that green sine wave, if that looked the same as this yellow one, really ridgy and distorted like that, then that would mean you had a lot of harmonic distortion on your current, on your voltage as well. As you can see, we've got a it's a PSC motor here. Got the current clamp there, clamped on the main line coming in. I think a lot of that, you can see the peak for the current. The yellow line is the current, green line is the voltage. With a good capacitor, those two would line up. Zoom in a bit, and you can see they're out of phase. So yeah, it looks pretty cool. You can turn the peak amplitude down, turn it up, zoom out some. You can see that phase correlation properly. Okay, so I just popped in a 10 microfarad cap. We want to see what this waveform does, if it's a little bit more in phase. Should be. There it goes. Oh yeah. Pop that into auto. I mean, if anything, it looks a little bit more out of phase, to be honest with you. See what the power factor is. 0.86. Probably needs a 12.5 capacitor. Maybe even a 5, I'm not sure. I'm not going to sit there and try a bunch of different ones, but you get the point. It's a 0.86. Just going to save it. That'll work.